Hello everyone, we're on a blank screen here and we are going to discuss, before we get off into SketchUp and a number of other things, the concept of a transformation matrix. So if you get involved in any 3D graphics, you have to realize that it is somehow, some way, some form stored probably in an X, Y, Z coordinate system, which could also be described a number of different ways, but one would be with a radius, an azimuthal angle, and an elevation angle. So there's two ways you can describe these things, but we're going to confine ourselves right now to X, Y, and Z, realizing that you could typically think of this as a right-hand coordinate system, and you could do the same thing with a left-hand coordinate system, and that literally means you talk with your left hand, and then things would be described as a northing and an easting and an elevation, and also the same type of angle here. So we have to realize that if anything, any single grouped thing, which would be called in SketchUp, a component, some SketchUp, a component, or a group, or a image, okay, anything that's kind of a group of things will be stored with a transformation. So a transformation essentially is stored as a matrix, and I could have this wrong perhaps, but the matrix for something that is at 0, 0, 0, which goes here, at no particular angle, everything is kind of straight up, will look like this: 1, 0, 0, there's the translation, 0, 1, 0, there's the translation, 0, 0, 1, 0, and then 0, 0, 0, 1. So if something was put at coordinates 0, 0, 0, at a scale of 1, see these things here, and was just basically had a 0 azimuthal angle, so theta equaled 0 and phi equaled 0 for all intents and purposes, it would look like this. This would be stored, a transformation would be stored for every instance of a component, group, or image, every instance. And so what you're going to see as you look in the code, that if you're going to add a component someplace, you first, one, define a transformation. And we'll do that in a little bit. And then use this statement. Entities dot add underscore instance. And then you add basically the name of the definition here. And then the name of the transformation. And these might be mixed up. Transformation. Yeah. All right, so this sense of everything being described by a 4 by 4 matrix, which within it is buried a 3 by 3 for rotation and scale about 3 axes, and here, which is about moving left and right, and this one here is just kind of makes everything work. And that everything then that's inside the group is stored this way. Everything in space can be stored by an X, a Y, and a Z, and then 1, dot, 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 the nth X, the nth Y, the nth Z, 1. And so very often what you see is when you take this and multiply it by that, you get the thing. And that pretty much is how the mathematics starts to work, is that we really want to delve into how this behaves, because this pretty much just describes things in terms of an X, Y, and Z position in 3D space. Later on you can look other programs dealing with radial work, but this for the most part is the sense. So let's define some terms, and we're going to do that now before we go into the program. Let's go insert, new slide. So in the programming, in Ruby, which is the programming language, in Ruby, a definition is a repeating shape like either a component, a group, or an image. So they all get stored in this place called definition, and they you begin counting definitions at definition 0, 1, 2, 3, ad infinitum. Now definitions can be made up of other definitions as well, so you get into this kind of idea of nesting. So the definition is a repeating shape, and all these definitions are then, when you bring the repeating shape in, so when repeating shape enters the draft design plane or enters the design space, they become something called an instance entity. So it becomes an instance. And so whereas to make a line, you might do something like this: entities dot add line open point 1 comma point 2. To add an instance, you would do this: entities dot add underscore instance, and then you would open it with the name of the instance, the definition, and then some transformation. All right, so very, very rough, and we're going to kind of type over the top of this. I'm just trying to think out some ideas here. Let's look at the original statements, and then we'll call it a day. And we'll show you that these web editors, or these web counsel, Eric Shriver and Jim Foltz. So here's the first statements. You need to be at the beginning of any kind of Ruby routine, you need to define the model. So it looks like something like this: model equals Sketchup, something like this, active model. And what you'll start to realize, I'm going to start having to do a better job of lowercase and uppercase and symbolage. But there's a statement that says that. There's a statement that says this: entities equals model dot entities. And what that said is, it's taken the thing that you've defined here called model and then told it that you want to get the entities that are part of that, or define something that is keeping track of the entities that are part of that model. You also add a statement that says this: selection equals model dot selection. That's to keep track of what you've grabbed at the time. The next one becomes one of the more important ones, and that is this: definitions equals model dot definitions. And now what you have is, in this data structure called definitions, you have a list of all the definitions that are in the model. And then finally, I believe the standard starting one would be something like this: view equals model dot active underscore view. Now, these statements, and they might not exactly be correct here, are the starting point of anything that you're going to do within Ruby. Later on, you can realize that something like definition 0, so I could say this: my thing equals definitions, and you use hard brackets here, 0. Your thing equals definitions 1. And what that means is there's something now called my thing that takes the first instance in the definitions, which is probably a component, and your thing takes the second. So as we start doing the next two statements, and we'll quit it there, when I say this, then entities dot add underscore instance open parentheses, if I now say my thing, and then even without making a formal definition of a transformation matrix, I add 0, 0, 0 in hard brackets, it's going to bring an instance of my thing at the origin. And then if I do the same, entities dot add underscore instance open parentheses your thing, comma, and I do this 0, 0, 10 in hard brackets, yours will be placed 10 units above mine. And that's pretty much what Martin Reinhardt talks about in his, I think, something about animation and whatever else. So this concept here, so to just kind of take you to that before we close out here, I'm going to go ahead and minimize that, go into Sketchup and show you what this code looks like inside a program. A very simple one. I'm going to choose a template, and I'm not even going to run it. I'm just going to have you look at what it looks like when we open it up. And realizing that what you need is SketchUp 7 or 8, and then something called either Web Console by Alex Schreiber, or it's not really wanting me to do that, so we'll see how it goes here. Problem with real time. I think I just have to do start using SketchUp. And there it goes. It's going to come up. I'll keep it within. I'm going to show you what when that code looks like. So right here in that Ruby code editor, I can actually go out and look at one I've done before. And I think simple points move is something that might be realistic here. There's what the statements look like. I was wrong on the double colons, but model is defined, entity is defined, selection is defined, and definitions. And then this is making a set of points, and then taking my thing and defining it as the first set of entities, not definitions, and then going through and doing the transform. So that's one similar statement to what I just did. I'll go ahead and open up another one. Messing around Ruby, and here you see in this case I am defining the same things in the front and then doing a loop with some mathematics, and I'm adding an instant where I go through and adding some based on some sines and cosines. I'm adding an instance, and if you notice there, the first one is the name of the instance and the second one is the transformation. So as we start talking about transformations, I want to finish up with that back in PowerPoint, and that is this. SketchUp deals with transformations many different ways, but in reality probably the most organized way for students, I would believe, and that's students of all ages, whether you are in 10 or in your 10th career, to remember that SketchUp will take them as a list of 16 where the numbers on them are this: 0 position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So if you want to go to this position, so you want to change the Y, it would be, if the list was, or the array was A, it would be A in the 13th position. So if you wanted to change this position, it would be A in the 12th position, and if you wanted to change this position, it would be A in the 14th position. So if you wanted to change the X, the Y, X wanted to go to 10, Y you wanted to go to 20, and Z you wanted to go to 30, you would add a statement like this: A12 equals 10, A13 equals 20, and A14 equals 30. That, of course, was once you define A as to be some list of 16 variables or 16 places. All right, so that's 15 minutes. We'll play around with that and teach kids how to move things around even before we get them to draft, because a lot of the drafting stuff you'll see should be done experientially, would be my opinion. Thanks for listening.